You may recall that when we've got right angle triangles, we can use Pythagoras' theorem, which is c squared equals a squared plus b squared, to help solve that and find the lengths of sides, etc. And we can use trig ratios, and that's sine, cos and tan. And to find the angles, we can use sine to the minus 1, cos to the minus 1, and tan to the minus 1. Okay, that will allow us to solve right-angled triangles. So right-angled triangles only. But what happens if we've got a triangle that is not right-angled? So we need to have a strategy for solving them as well. One of those rules is the sine rule. So sometimes it's a bit difficult to draw a triangle that's not right angled and not equilateral and not isosceles. Anyway, there we go. So we've got A, B, and C. Clearly none of those angles are right angles. Opposite angle A, we've got side A. Opposite C, we've got side C. And opposite angle B, we've got side B, lowercase. And the sine rule says is that the length of side A over the sine of angle A is B over sine B. So the length of that side divided by the sine of that angle equals the length of B over the sine of B. Notice that this is not a right angle triangle, even though, sorry, not a right angle triangle, this is not a hypotenuse, even though it is opposite the largest angle, it's still not called, the hypotenuse only happens in right angle triangles. Not only is that those two the same, but it is also equal to C over sine C. Now, if we flip these three upside down, they are also true. So sine, another way of quoting the sine rule is that sine A over A equals sine B over B, and be careful where you put your capitals and lowercase, they're both very different things, equals sine C over little c. So those ratios are the same. Now you don't use this all at once, you might use that, those two, or you may use those two, or you may use that one and that one together, depending on what you're given in the triangle. So I think probably the best way to do it is I'll just work through an example here. You have to be if we're only going to use one set of these ratios, this one and this one, well, you need to know 3 of those 4 to be able to use that, to be able to make it work. So let's have a look. We've got A, B and C. You've got 22 centimetres up there, 130 degrees, and we've got 18 degrees. All right, and we want to work out the length of B. So we want to work out, so length B. Okay, what have we got here? Sometimes it's best to write the whole 6 things down so you know what you've got. So we've got angle A is 130, angle B is equal to 18, these are degrees, angle C we don't have. All right, the length of side A is equal to 22. The length of side B is unknown, and the length of C we don't know as well. So it looks as though if we use A over sine A and B over sine B, we will have 3 of the 4. So we won't use C over sine C because we don't know those. So once again, you must know 3 of the 4. So we're after B. So I'm going to write it like this because it's easier to work out the unknown when it is on the top. You can still work it out on the bottom. We can still use these two, but I'll use this one here. So we've got, quote the rule first, A over sine A equals lower b over sine capital B, capitals for angles, lowercase for sides. What have we got here? We've got A is 22 over sine A, sine of 130, equals B, we're trying to find, and sine NB is equal to 18 degrees. Now you don't have to work anything out with your calculator yet. We can get B by itself. Now to get B by itself, we want to get this by itself. We multiply both sides by sine of 18 over 1, multiply by sine of 18 over 1. That will allow those to cancel out, and we get B over 1, which is B. So B equals, now it is common to put any numbers before the trig ratios, so we'll go 22 sine 18 all over sine of 130. And using our calculator, we will get, you can do that all at once, 22 times sine 18, then hit equals, and then divide by sine 130, and we'll get 8.87. And because we're working here in centimetres, we've got our answer. So that's how the sine rule works. If you're not given any letters on the diagram, you're just given a triangle, you can put letters on where you like, bearing in mind that opposite angle A will be side A and so on. Use that convention. We then go through and quote the rule. You must have 3 of the 4 to be able to work it out, and that'll allow you to work out the missing one.